Swayam Prabha. Digital India. Educated India.
Hello, namaste. Welcome back. We are in the last lecture of the module 2, where I would be showing you how different methods of generating a data for a GIS is there, whether it is digitization, whether it is manual digitization, automatic digitization, what kind of different methods can be used. So, probably this would be your first class of looking at actual data. So, if you have certain data by your data sets by yourself, maybe if you have certain certain equipments that I would mention it here, I would say that please start looking at how you can process the first set of data. So, how do you put it in a geographic system? How do you convert it as a different tool to understand data, to extract data? That will go ahead in the next class. But in order to create a input data, this may be a first step. So, in case you have certain data sets, please start looking at it. So, these are certain concepts that I would cover. One is the data inputs to GIS, what are the different digitization methods, what are the errors that is in digitization. This is extremely important for everyone to understand what are the different errors, so that it can be corrected in your entire data set. So, when I say data input involves digital encoding of both geographic and attribute data. So, for example, attribute data can be in the form of a spreadsheet, it can be a data management systems. So, any of those data management system elsewhere can also be an input to your data management system, or it can be just as a spreadsheet, basic spreadsheet. Okay. When you look at the geographic data, you will have to do a coordinate entry, or you will digitize it, and you will scan it. When I say geographic data, it is the data about the earth surface or a phenomena or an object. Okay. Whereas when I am speaking about the attribute data, these are those data which adds value to this geographic data. So, when you are looking at geographic data, you are basically looking at it as an entity, something like this. Okay. But if you add a value saying that this is maybe a regions quadrant, or this may be a particular road, this is also a road, it is a name of the road and length of the road, etc. These becomes your attribute data. This can be in the form of a spreadsheet. Okay. Whereas geographic data has to be done with a coordinate entry, scanning, or digitizing. So, let us look at how we actually generate each of these geographic data. So, when we look at data input, to be honest, it is the conversion of a hard copy to digital maps is the most time consuming task in GIS. So, it is almost 80% of the total project cost. As per the estimate, it is about US 10 billion annual market. So, when you look at US dollar 10 million annual market, it is extremely big. Conversion of any hard copy digital maps, for example, the maps that is in 1970s, 80s, etc. So, these are extremely important in terms of understanding the evolution, temporal evolution of the Earth's surface. Then these are quite labor intensive. You need some extremely talented youngsters looking at the data and digitizing it. It is extremely tedious and error prone. So, you may have a lot of errors. So, when you are creating data using this conversion of a hard copy, then it is extremely error prone, because most of the hard copy data or hard copy maps will have huge amounts of data. Maybe even you will not be able to look at it more the way it is printed. So, that is extremely important, that creates an error basically. Then database development sometimes becomes an end in itself, because it doesn't know how the database has to be created into a how the data model has to be created. So, understanding this, the first way of your data entry is in a form of a keyboard. So, when we are looking at a keyboard entry, it is basically the coordinate data, maybe like a lat long coordinates that you enter, that's shown something here. Okay. So, from it may be from a gazetteer, a listing of place names and their coordinates, it may be from a gazetteer, it may be from your census data, listing of name and coordinates, from locations recorded on the map. So, you take a map, you start entering in your keyboard different locations and different coordinates of each of these locations, the xy value. So, this becomes your first step of data entry. It may be from a keyboard, just creating a Excel sheet, or use sophisticated systems, something like a global positioning system. We will speak about global positioning system, how it works, how different systems are there, India's own indigenous systems, etc. But as of now, GPS are handheld devices which can receive certain frequency of wavelength of spectrum in order to measure distance, the geographical locations, etc. So, these geographic positioning system has also evolved over a period of time. So, in order to give us better data, better inputs of data, now you have extremely efficient systems in order to measure this data. It is dependent on what frequency the signal that your device is receiving, whether it is a frequency that has extremely precise positioning, or it is just a standard positioning frequency. We will look at all of these when we look at GPS. But when you are looking at global positioning system, this determines the current position based on signals sent by a number of satellites. So, as in theory, we need at least 3 to 4 satellites. Normally, it is a 4 satellite signals in order to give us a exact location on the Earth's surface. So, every place, if you look at the forest cover, it is extremely different. If you go into a forest and try to get a GPS signal, it may be extremely difficult to get a GPS signal inside a forest because of its cover. So, looking at such instances, there are certain issues that GPS can also provide. That is a disadvantage of GPS. You should have a clear sky. So, it may not be possible in a crowded region to get the GPS signals. Even for example, in urban form where it is completely crowded, your GPS may not work as efficiently as it has to be. For example, when you have certain mobile sets that you have GPS built in, assisted GPS built in, you can see that your positional accuracy is completely different from what is shown on your map. When it gives an accuracy of up to 1 kilometer, 500 meters, 600 meters, etc., because the signal accuracy it may be certainly bad. So, GPS signals can be converted into a digital form. You go to the field, you collect the data, you get back from the field, the same can be translated into the coordinates or into an Excel sheet by just a bit of conversions. That now you have lot of softwares which are bundled with this GPS systems, which can easily give you the geographical data as it is. So, now as cheap as 6,000 to 8,000 you get handheld GPS, and moreover you have extremely good assisted GPS in your mobile phones. But only thing is that this assisted GPS should be on a precise positioning which is normally not there, and your whatever the data systems are there, that should be extremely good. So, most of these signals are actually calculated through your wireless stations that are there around you. So, the next part is manually digitizing. This is using a digitizing tables. So, something like this, probably when we started looking at GIS. So, this is how we started with the digitizing tables. In today's context, this does not exist. No one uses such tables in order to digitize it. So these can be 25 by 25 centimeter of tables to 200 to 150 centimeter of tables. So you have a digitizer. So if you see in this person's hand, this is a digitizer, okay, which has electronic signals. As you move and click on that particular position, based on single click it gives you a point. If you click and move on and stop at a particular point, it gives you a line segment. If you move for the entire polygon, it gives you the entire polygon. So that is how you start digitizing using the manual digitizing tables. So this is extremely tedious. If for example, if you have, let's say, a city map, extremely overgrown city of any Indian cities, if you have a city map, it is extremely difficult for you to identify an entity and put it using a manual digitizer, and takes a huge amount of time and effort. Then how do you, if someone asks me how do you digitize each of these, first you fix a map or a aerial photograph on a digitizing table. In case someone wants to use it and has this facility, please look at it. Looking at traditional ways of how it started digitizing is also important and may be useful. Select control points, that's using a tick, okay. Easily identifiable points with real known word. For example, as I pointed out previously, the framework data, okay, maybe in roads that are intersecting, or you have very well known road segments, or certain points which are extremely identifiable in a map. So in the real world, so and that things that have not changed over a period of your study, so these can be your control points. So please look at it more carefully, because control points define how accurate your data is, otherwise you will not be able to get an accurate data. Then trace features to the digitize with the pointing device. So you go into, for example, let's say I am trying to digitize this, I'll start tracing this particular feature, okay. When I say point click a position where the direction changes. Where if it's a stream mode or line mode, your digitizer automatically records at regular intervals. Then if it is a stream mode, only thing is that when you look at the point mode, it requires extreme well judgment by the user. For example, let's say I am trying to click on yes here, okay. If even a slight change will change its geographic coordinates, okay. So that has to be looked at, because that's a point, it's a single point. If you click, it's done, fine. So when you are looking at a stream mode, it creates a lot of redundant coordinates, because you are trying to push it something like this. So in case you are not pushing it in a proper line segment, it may create a lot of tangles, because of which you will have errors in your entire data set. So that is why the manual digitization is nowadays avoided, but previously it was the thing that people used in order to build up the data set. So when you look at the entire digitizing table, you have a grid of wires in the table that creates a magnetic field, something like this, okay. So at the ends of this table you have the grid of wires. Then you have XY coordinates in the digitizing units are fed directly into a GIS software. High precision, you should have a very high precision in coordinate recording, otherwise you are going to be horribly wrong. If any of your data set don't have a precision, you are surely getting a wrong coordinates into your data fed. So when you start analyzing it, you will not sit at a extremely right point. You may have a shift of points, which creates a geographically a wrong notion of representation. So the other method is heads up digitizing. So for example, if you don't have a digitizing table, so how do you do it? So use your own monitor which has capacity touch to use as a digitizer. So these features are traced from a map through a transparent sheet attached to the screen, okay. So for example, there is a map attached here, you have a transparent screen. So you use this method, but what happens with this is extremely low accurate, So if you are representing a very coarse resolution, then you may use it, but this is extremely accuracy is extremely low, so people avoid it at measure of times. If you see, there is a person here who is actually digitizing it using a heads up digitizer. So, or for example, to represent, if your monitor is something like this, that is normally these monitors are I mean have a touch display. So, if you put your map something like this, start clicking on this particular mouse cursor and start digitizing it. So, that is how you do an heads up digitizing, but nowadays you do not have any heads up digitizer used in many of the places. Okay. So, heads up digitizing can also be done something like this. There is a scanner that keeps running and creates raster images. This is one of the images that I have seen, I have gotten Google. These systems are never there in last one and a half decade. People have stopped using such devices. What operator does is he follow the lines on the screen in a vector mode as it scans. For example, the paper scan, if you have seen a scanner in any of those any of a Xerox machine, it scans smoothly from one end to the other end and moves back. So, the user also starts digitizing it from one end to the other end and moves back. That is how digitization is done. Okay. If it is a point, he does it with the point. If it is a line, it starts with a line, and if it is a polygon, he does it with a polygon. So, it does every part of a page one row by one row, depending on what the size of the scanning system is. So, that is how heads up digitization works, but nowadays this is not used much, but if someone has this facility also available today, you can have a look at it. It's actually a good experience of understanding how digitization happens. You can learn a lot of issues that you handle in digitization. Today it is more of automatic methods or digitization, manual digitization in your computers. I will also give you some examples of how you digitize. You have at least one practical class where you actually do the entire digitization of your map. So, that would be given as one of those practice sessions that you may have to look at if you have to understand it better. So, when you look at digitization errors, this I have already shown you before. The first error that you see is undershoot, which you can see here. There is one line segment here, there is the other line segment here. So, but this line segment for to be exactly correct has to fit into this particular segment, or if it is a road that is crossing something like this, okay, this has to fit in something here, but it is undershooting by this amount. That is called an undershoot. So, whenever you are having a digitized error as undershoot, this has to be corrected before you processing it as into a database. Okay. Then you have overshoots. For example, this particular line has overshooted this particular point. Then you have dangles, something like this. You have two line segments that had to meet, but it is dangling. It is separated by a space vertically or horizontally. So, that is called dangling. So, that has to be corrected. You look at which data reference is correct and correct the other vector data under the line segment. Then you have spurious polygons. I have not shown here certain polygons which may not be particularly there. Then you have switchbacks, something here like this, where it had to be something completely like a line segment, but when you are digitizing, you went and overshoot and came back and you digitize the same line. So, certain errors that occur. So, the switchbacks is very commonly seen in most of the digitized data sets. So, look at these certain errors like this. So, this has to be corrected. Then you have loops which may have fallen probably when, for example, if you are digitizing there, after certain point of time you push your mouse, so it creates a loop. Okay. So with a click it creates a loop. So such things are very commonly seen in most of the databases, which has to be corrected. And you have knots sometimes like this. So all of these errors have to be created and has to be rectified. But one specific thing that has been developed over a period of time is most of the GIS software today has developed certain tools which can actually look at all of these errors in automatic way. Just by a click of the mouse button, you can actually correct most of whatever I have shown, most of the errors that I have shown. But there are certain digitized places where the software cannot interpret, okay, or correct it. So that is where the manual error correction has to be done. So there needs at least 5% of manual effort in order to correct the entire data set. So when we look at digitizing errors, I have given another example something here. So if you look at it, this is the entire vector data set that I have developed. When you see this is a dangling node. See, this had to be connected somewhere, but it is dangling out. Okay, how do you find out this is a dangling node? If you see the original data set, you can find out why it is a dangling node. There is, if you see, most of these are actually labeled, but there is a label point that is actually missing here. The point, if you see here, all these have labels, okay, whereas this particular polygon does not have a label, okay, or connecting line segment does not have a label. So this has to be corrected, that is missing. So when you see very carefully here, okay, if you see this in a more careful way, this particular line is crossing and not setting up the node. That is also a mistake that has to be corrected. Each of these line segments have a node, so this node has to be connected. So there is that's another mistake. And when you see this entire thing, when you are creating a particular line segment, you have clicked somewhere in between and create a node, that becomes a pseudo node which has to be corrected. So these are certain errors which are surely would be there in your entire data set. So please look at some of these nodes. There is overshoot here. It was supposed to stop here, but it went on across here. This is an overshoot, and when you see this, there is an undershoot. So all of these things has to be looked at if your data set has to be proper. Then when you look at the digitizing errors, any of the digitized map requires post processing. It cannot be without manual intervention. At least 5 to 10% of post processing has to be done manually. Check for any missing features. That is extremely important. I am sure in a large map you would have missed a huge amount of features. So please do a secondary checking with the missed features. Connect lines, that is very important aspect, but it can be done automatically nowadays. Then you have removal of spurious polygons. This is also done by certain tools automatically, but have a secondary check so that you are sure that your data set is clean. Then some of these steps also can be automated, but always have a look at with the secondary way of looking. Then other method is scanning. It converts an analog map into a digital map. So now most of them are electronic. They are drum scanners and flatbed scanners. Most of scanners now used are the flatbed scanners. So it can the scanned file can be easily converted back to a vector format and digitized. The raster to vector conversion can be done easily, and vectorization is now a popular instead of digitizing. This is the most popular method now used by various researchers across the globe or practitioners across the globe who are converting the hard maps into a digital format. So this is more easier and less cumbersome in order to convert a hard map into a digital map. So normally a scanner output is a raster data. It usually needs to be converted into a vector representation. Manually is done by on-screen digitization, where you have we will also look at how manually we can create. We will use in a practical class, we will create one map manually so that you understand how the vectorization is done. But nowadays, once you have a raster data, most of the process is automated. So raster to vector conversion is done, then you have line tracing. There is an software which is called as MapScan, can be extremely useful in such issues. So and you have certain disadvantages, often requires considerable editing. I am sure most of the automated things needs considerable editing. You need to put in a lot of efforts in editing the secondary or have a secondary check. Then raster data files normally consumes huge space. Normally the data that you have created may be from your own data sources, maybe even through digitizing, can sit maybe in about 50-60 MB depending on what size of data or the area that you have considered. But when you look at the raster data, it may go up to a GB or 2 GB or 3 GB of data, or even hundreds of GBs of data depending on what area that you have considered. So but scanned images cannot have attributes, keep that in mind. So scanned images, until unless these are geographically connected, then the database is created, only then you can have attributes. You can extract attributes from the scanned images, but they cannot have attributes by themselves once you have scanned it. Okay. Good resolution maps are extremely important in order to create a scanned data. If you have a very bad resolution, that is not giving your data model in a proper way, you will not be able to, or entities are not represented in a proper way, you will not be able to identify what entity is there in the map. So you need extremely good resolution, extremely clear map in order to scan it and convert it into a digital map. So this is one of the big disadvantages that you can see as a scanning. So for example, there is an automated vectorization here. This is your scanned map. Okay, operator sets the global parameters and the system converts the entire map. Okay, so you can see here, these are certain maps that is created. This is a line that has been created using this. Okay, so how do you do this? Operator points to a specific line. For example, this line, if I keep pointing, and system start converting that as a line. So that is how the automatic vectorization works. Okay, so as scanning, it can be direct use of any scanned images, it can be scanned air photos, digital topographic maps. Pre-processing can be can reduce editing required. So lot of pre-processing of the photo can be done in order to reduce errors. Any trace the important features first. That is my advice to anyone who is using such thing. First trace important features manually, then give the rest for automated extraction. Don't do automated extraction always, you would miss a lot of features. Trace it first, then use an automated extraction. Scan clearer, simpler maps, that is the best way. Okay, otherwise it's going to be tedious. So when you look at digitization and scanning, the source for a map is registered in the real world coordinate system with projection and associate parameters. Usually these are recorded in meters or feet. Okay, so digitized coordinates are recorded in digitizing units. So that depends on whether it is a centimeter, inches from the table's origin. So that has to be very carefully looked at. How do you convert the real world phenomena into digitized world phenomena? So when you are using a digitizing table, please keep this in mind. So digital the way of digital measurement is very different from your real world measurement. So the conversion has to be significantly different. So please look at this and record it in your map or in your digitized format, so that the unit conversion is done in a much proper way. So in order to summarize, we have various methods of data input to GIS. One is manual digitization, scanning, the keyboard entry, and GPS. We have looked at all of these. We will look at GPS in much more details on how the signal is there, what are different type of systems, do we have any parallels to GPS, indigenous ways of which has a parallel to GPS also has been developed. We look at all of these. Then error in data entry. This is extremely very important and very crucial in developing a data set. So the manual error that may creep in, then you have digitizing errors and inconsistency. So all of these has to be addressed before you have a data set. But my suggestion is that please go into certain data repository which I have already explained. Even it can be your data.gov.in. Download certain data sets, small data sets. I don't expect it to be extremely big data set. If possible, look at how the data is there. Look at the data, get a feel of a data. So that is the first way of learning your data. If you understand the data, have got a feel of data, then you know what is there on the ground. If possible, visit that place. That's how you start looking, you start being a GIS person. So maybe take up this work, look at how you can get different data sources, different data, and look at how you can manage the data. Thank you very much. Let's meet in the next class, wherein I would look at the next module of lectures. Thank you.